Day 103 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. You know how we do. You know where to find us. We're here every day doing a LeetCode problem every day. So if this is your first time at this channel, welcome, welcome. If this is your second, third, whoever knows how many times on this channel, welcome back. Welcome back, y'all. You already know how we do. We're doing a LeetCode problem every day in Swift, and we're trying to build the Swift programming language community as a whole. So before we get started, y'all, click this subscribe button right over here. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers out there to the comment section right now. I need you to drop 2 bank emojis in the comment section so we can run this engagement up and we can help get this content out to a broader audience and help more people get interested in the Swift programming language as a whole, y'all. Now that we got all that out the way, I know why y'all are here. And today we have question number 1365. How many numbers are smaller than the current number? The difficulty level is easy, so you already know how we do. We're going to keep the solution as simple and easy to understand as well, because there's no point in writing code that nobody understands, whether you're writing it for your personal project or you're writing code at work. It's best to write code that's going to be easy to understand for people who come behind you. So if we want to understand the code, the first thing we're going to have to do is understand the question. So let's see what the question says. It says, given the array nums, for each nums I, find out how many numbers in the array are smaller than it. That is, for each nums I, you have to count the number of valid j's such that j does not equal I and nums j is less than nums I. Return the answer in an array. Okay, so let's see how we're going to do this, y'all. So let's look at example 1. Example 1, we have the input nums. It's an array of integers 8, 1, 2, 2, and 3. Then the output is 4, 0, the output is another array of integers 4, 0, 1, 1, and 3. So let's look at the explanation to see how they got it. It says, for num 0 equals 8, there exists 4 smaller numbers than it, 1, 2, 2, and 3. So if we look at num 0, which has a value of 8, and we count the number of numbers in the array that are smaller than 8. So we go 1 is smaller than 8, 2 is smaller than 8, 3 is smaller than 8. 2 is smaller than 8, and 3 is smaller than 8. So that's 1, 2, 3, 4 numbers that are smaller than 8. So we're going to put a 4 right here in the place of 8 because that's how many numbers are smaller than it. Then let's look for the next one. It says for nums 1 equals 1 does not exist any smaller numbers than it. So for index 1, which has a value of 1, if we look at all the other indexes, none of them have an element that is with a value that is smaller than 1. So we're going to put a 0 right here for index 1. Then we're going to come over here to index 2. It says for nums 2 equals 2, there exists one smaller number than it. So here we come up, index 2 has a value of 2. We look at 8, 8's not smaller than 2. We come to 1, 1 is smaller than 2. We come to 2, 2 is equal to 2, but not smaller. And then we come to 3, 3 is not smaller than 2 either. So there's only one number that's smaller than 2, because it says right here, nums j cannot equal I. So we cannot count this 2 in our count. So there's only one number smaller than 2. So we're going to put a 1 right here for index 2. Then we're going to come over, it's another 2. For index 3, it's a 2 again. So it's the same thing. There's only one number that's smaller than 2 in this whole array. So we're going to put a 1 right here. Then we're going to come over and look at 3. So when we come to 3, index 4, 3, there exists three smaller numbers than it, 1, 2, and 2. So if we look at index 4, which has a value of 3, and we look at the rest of the elements in the array, we look at 8, index 0 is 8, that's not smaller than 3. But index 1 is a value of 1, that's smaller than 3. Then we look at index 2 has a value of 2, that's smaller than 3. Then we look at index 3, that has a value of 2, and that's smaller than 3. So overall, there are 3 numbers that are smaller than 3. So we're going to put a 3 right here in the index 4. So what these numbers in the output are doing, they represent how many numbers are smaller than the corresponding element of that, or the corresponding index of that element. So for 8, there are 4 numbers smaller. For 1, there's 0 numbers smaller. For 2, there's 1 number smaller. For 2, there's 1 number smaller. And for 3, there's 3 numbers smaller. And that's how we get this output right here. Let's look at example 2 so we can really bring it home and make it make sense. So same thing, we have input nums, an array of integers 6, 5, 4, and 8. The output is 2, 1, 0, and 3. So in this case, we look at 6, right? We count how many numbers are smaller than 6. 1, 2. So we're going to, 8's not smaller than 6, so there's only 2 numbers smaller than 6, so we're going to put a 2 right here where the 6 was. Then we're going to do the same thing for 5. There's, out of all of this whole array, there's only 1 number smaller than 5, so we're going to put a 1 right here in place of that 5. Then we come over to 4. There's 0 numbers in this array that are smaller than 4, so we're going to put a 0 in place of 4. Then we'll come over to the last index, 8, which is index 3, and there are 3 numbers. They're all smaller than 8, so we're going to put a 3 for that in place of the 8, and this would be the output, 2, 1, 0, and 3. So let's look at the last example in case it's kind of a trick question. We have input nums, an array of integers 7, 7, 7, and 7. 0 numbers are smaller, so we look at 7. 0 numbers are smaller than 7, so we put a 0 right here, because remember, I cannot equal j. So there's 0 numbers smaller than 7, so we put a 0 in place of that 7. We come to this 7. There's 0 numbers smaller than this 7, so we put a 0 in place of that 7. Then we come to this 7. There's 0 numbers in place of that 7, so we put a 0 right here for that 7. Then we come right here to this 7. There's 0 numbers smaller than 7, so we put a 0 in place of that 7. And that is the logic behind the question. That's what they want us to ask. They just want us to ask how many numbers are smaller than the current index that we're on, and they want us to return that number in an array with the rest of the numbers. So now that we understand the question, y'all, let's get into the fun part, the code. And the code, you already know it's not that difficult, so let's get into it. First thing we're going to do is we're going to declare a variable called count array, and we're going to set that equal to an array. Then we're going to say repeating :0, comma, count. Then we're going to say nums.count. So what this is going to do is this is basically, it's not creating a blank array, but it's creating an array. It's like creating a blank array, because we're going to use it and we're going to change it. But what it's doing is it's not blank. It's creating an array of all zeros up to nums.count. So however many numbers in nums, that's how many zeros there's going to be in the array, just to hold place until we get to change it a little bit further on in the code. So after we create that array, or that variable count array, we are going to create a for loop, and we're going to say for, open up the parentheses and say index, comma, current num. Then we're going to say in nums enumerated. Now we're going to say nums enumerated because what nums enumerated does is it gets us the index and the value. It returns the index and the value of that index, and we are going to want both. So that's why we are using nums enumerated. Then we're going to come down here and we're going to say count array index equals nums dot filter, open up the brackets, we're going to say current num greater than $0. So what this is going to do is this is going to create each index and count array is going to be filled with the number of times that each element occurs, right? So this is going to filter out then we're going to put .count here too. But this is going to filter out every time that the current num is the greatest. and then it's going to return the dot count. Then we're going to come down here and we are just going to say, excuse me, return count array. And that's all she wrote, folks. Let's run it and see how it runs. Fingers crossed, fingers crossed. And there it is, y'all. There it is. So let's submit it and make sure it still works, though. You never know. You never know. It'll switch up fast on you. And there it is. Ooh, now we definitely have to get these numbers up. But look, this is a great solution to understand easily how to get the job done. But we got 32 milliseconds beats 6.94% of users with Swift. Now we definitely got to get those numbers up, but this is an easy solution to understand. So we really want to understand the code as we're going on, because we're going to want to be able to reproduce the code for certain questions. We might want to use something that we learned in this code, and we're not really going to learn anything if the code is hard to understand. So at the end of the day, we'll worry about the speed and the percent of people that it beats later on in the course, y'all. We're all still learning here. We're not really focused on time. We're just focused on understanding the problem and being able to solve the problem. Once I feel like we get to a point where we can solve the problem easy, then we'll move on and start worrying about the time complexities and all this. But first, we got to walk before we crawl. So we're just going to make sure that we can solve the problem first, and then we'll worry about the time after that. So get one more look at the code, y'all. One more look at the code. And I'll see y'all tomorrow for another day, another LeetCode problem. Peace.